Okay, we're supposed to find the equation of the tangent line to this curve at the point where x equals 2. And here's a picture that illustrates what's happening. This green graph is the graph of 1 plus 3y equals xy. And it looks like 2 comma negative 1 is on the curve. You can find that by putting 2 in for x and solving for y. You get negative 1. Here we kind of show that it's possible to do this problem with an explicit formula for y because it's easy to solve for y. In other words, if I say that 1 equals xy minus 3y, factor out the y, and then divide by x minus 3, I get y in terms of x. So you can also find the derivative explicitly, which I'll show on the next board. Okay, I'm going to share my screen too here for a second. I'll go to Desmos in a minute. But if I go to board 2, here I'm showing finding the equation of the tangent line, finding y prime explicitly, or implicitly over here, by using implicit differentiation. So the derivative is 0, of 1 is 0. The derivative of 3y is 3y prime. So I have to use the chain rule. I'm assuming that y is a function of x. So I have to take the derivative of the inside. I just don't know what the inside looks like. Even though I actually do, because it's 1 over x minus 3. Now over here we have to use the product rule. First function, which I'll call x, times the derivative of the second, plus the second function y, times the derivative of the first, which is a 1. I could have put a 1 here to show that. And now to solve for y prime, I'll subtract this term from both sides, factor out the y prime, divide by 3 minus x, and there's a formula for y prime in terms of both x and y. What is the slope of the tangent line when x equals 2 or y equals negative 1? Well, you put 2 in for x and negative 1 in for y, and there's the slope. Now, if I want to do the same thing when y is defined explicitly, I can rewrite the function this way. Employ the power rule, reduce the exponent by 1, rewrite it this way. What's the slope of the tangent line when x equals 2? Put 2 in for x right there. You still get negative 1. Okay. So if I go back to board 1, the equation of the tangent line using point slope is y minus a negative 1. That's the y coordinate of the point that we're trying to find the tangent line, equals the slope, which is negative 1, times x minus 2. And that's where this came from, and here I converted it to slope intercept. Okay. Now if I go to Desmos, I just wanted you to see how you can code Desmos to show the tangent line at any point on the curve. When x of 1 is equal to 2, there's the tangent line. But for any other value of x, you can also get a picture of the tangent line at any point. And that's what this is right here. Point slope, f prime of x of 1 times x minus x of 1. Okay, there you go. Hope that helped. If you have any questions, post a comment.